Hello Year 13 chemists, welcome to TP's Chemistry Cuts. In this clip we carry out a simple buffer calculation and then look at the effect of diluting a buffer.
Okay, so in the last lesson we went through all the background of what buffers were and the formula we're going to need to carry out calculations of buffers. So what I thought I'd do to start this lesson is to do a very simple calculation involving a buffer. Okay? And in this question on the board, we're given both of the concentrations of the weak acid and its conjugate base, and we now need to calculate what's the pH of that buffer we formed. Okay? So, as we do with all of these problems, we've been given Ka, so we need to write an equation for that. Okay? So, the equation for the dissociation of ethanoic acid is very simple now, hopefully. People shouldn't be struggling with this anymore. And the equation relates the weak acid to its conjugate base, and that's what we need if we're going to do any calculations involving a buffer where we've got both of those. So if we write out the expression for Ka, as this isn't of any use to us yet, because what we're wanting to do is to calculate the pH. The thing we want to calculate is this value here. So we need that to be on the left-hand side of our expression. So if we rearrange this, it becomes Ka times concentration of the weak acid divided by the concentration of the conjugate base. And so we can just plug in the numbers we've got. And I say this every time, but I'll go through it again. Always highlight, if you're not very good at maths, highlight the numbers you've been given. Pencil. Okay, so Ka is 1.74 times 10 to the minus 5 times concentration of ethanoic acid, which is 0.150, and that's divided by the concentration of ethanoate, the conjugate base, which is 0.0500. Hopefully that's it. Okay, so pH equals minus the log of H3O plus, which is equal to minus log. I've got to stop bullying you on camera, haven't I? Yes, you do. Somebody could work that out for me, please. 4.28. There's a very quick way to check you're in the sort of ballpark of the right answer. And we've got the same concentration of weak acid and conjugate base. This simplifies down to that divided by that is 1. So you get the concentration of H3O plus is equal to Ka. Yeah. So the pH is equal to the pKa because you take minus the log of both sides. Yeah. So if you work out what the pKa of this is, somebody quickly do that, minus the log of this. 4.76. Okay. Now, if we had equal concentrations of the weak acid and its conjugate base, then you would expect the buffer to have that pH. Okay. What we have here, though, is a higher concentration of acid compared to the conjugate base. Okay? So in other words, if we've got more acid there, there's more H3O plus in the solution, yeah? Does that make sense? Which means the pH should be less than 4.76. There's a higher concentration of acid, therefore lower pH, so it should be less than 4.76. So that's just a very quick way of checking it, because you're more than likely going to be given a pKa rather than a Ka. Now, what I want you to do is I want you to do the calculation, and I want you to calculate the pH of that buffer. Okay? So what we've done is taken the original one and we've diluted it down by a factor of 10. So let's go through this. So we highlight the two answers. You can see there's a very important point to make here. It comes as quite a surprise to a number of people that when you do dilute a buffer down, the pH doesn't change. In fact, all we're doing is changing these two concentrations by exactly the same factor. So the ratio of the two concentrations stays the same. So that's what you're actually looking at, is the ratio of the two concentrations. If it's staying the same, you're going to get the same concentration of H3O plus, and therefore you're going to get the same pH. So diluting a buffer does not change the pH, and that's a really important thing. Because if you take, for example, just an acid, a weak acid, if you dilute a weak acid, the pH will go up, because the concentration of H3O plus by definition goes down, because you're diluting it. Okay, and because the pH depends upon the concentration of H3O plus, and you're making the concentration of H3O plus less, the pH, which is the minus the log of that number, goes up. Now in this case, you're diluting both the acid and its conjugate base by the same factor, so this ratio stays the same, so the pH stays the same. Does that make sense? Did you want me to write that up? Okay, so that's just a very long-winded way of saying that the pH of a buffer depends upon the relative concentrations of the weak acid and its conjugate base. And because we're not changing that relative concentration, because you're diluting both by equal factors, then the pH doesn't change. Yes?
That's why you put bloopers in. Because you're just showing all the boring stuff.
This is the good stuff. This is chemistry. Don't listen to them, Trevor. Okay, so shall we move on then? Have a look at, so the very important point here. However, there is something about the buffer that has changed. What is it? If you've diluted it, you've not changed the pH, but what has changed? Volume. Yeah, the volume has, yes, but the concentrations have changed. But think about what it is the buffer has to do. You're not doing it as an academic exercise. You're making these buffers to carry out a job. Will the buffer carry out its job as well if you've diluted it by tenfold? No. And the answer is no, because there's a lot less acid and base in any volume of solution you're using. So it will keep a system at a constant pH, but it will be for a lot smaller additions of acid or base. So it's not as effective. Okay, it's not as effective as a buffer, but it still has the same pH. And the important part here is the buffer is less effective when it's diluted. So, in summary then, dilution does not affect the pH of a buffer, but it does make the buffer less effective. Yes? So, this sort of understanding this is very important. Good, isn't it? See, chemistry's not so bad after all, chapesses. See?
Keep things like that in.
No.
Yes. It'll give your audience like.
I don't want an audience. It's just here to help you.
It's like a buffer for like the content that you're giving us.
Sorry?
It's like a buffer for the content that you're giving us. You need the
Oh,
bloopers,
yeah.
or else you can't survive.
Oh my god, that's a perfect example. It is.
Because as Leslie said, the problem with this refocusing is because it's buffering all the time. That was Lizzie's job.
Good one.
Okay, so Okay, can I rub off this one at the end?
Yes.
You know, if I was the board rubber.
You'd be on the board.
Yeah.
Oh.
Well done.
Literally.
Do you want me to leave that one on?
Yes, please. Just leave them all.